Hi, this is the last video of this section, smoothing the noise in real-world data. In the last video we looked at generating controlled random datasets. In this video we're going to take a look at averaging data over a sample and plotting it using SciPy library and using the median filter. In this video we introduce a few advanced algorithms to help with cleaning the data coming from real-world sources. These algorithms are well known in the signal processing world and will not go deep into mathematics, but will just exemplify how and why they work and for what purposes they can be used. Data that comes from different real-life sensors usually is not smooth and clean and contains some noise that we usually don't want to show on diagrams and plots. We want graphs and plots to be clear and to display information and cost viewers minimal efforts to interpret. We don't need any new software installed because we are going to use some already familiar Python packages, NumPy, SciPy, and matplotlib. The basic algorithm is based on using the rolling window, for example convolution. This window rolls over the data and is used to compute the average over that window. For our discrete data we use NumPy's convolve function. It returns a discrete linear convolution of two one-dimensional sequences. We also use NumPy's linspace function, which generates a sequence of evenly spaced numbers for a specified interval. Function ones defines an array or matrix, for an example a multi-dimensional array, where every element has the value 1. This helps with generating windows for use in averaging. This is the code. We use NumPy's convolve function, which returns a discrete linear convolution of two one-dimensional sequences. We also use linspace function, which generates a sequence of evenly spaced numbers for a specified interval. One simple and naive technique to smooth the noise in data that we're processing is to average over some window and plot just that average value for the given window instead of all the data points. This is the basis for more advanced algorithms. Let's run the program. Here we can see how the smoothed line looks compared to the original data points plotted as dots. Following on this idea, we can jump ahead to an even more advanced example and use the existing SciPy library to make this window smoothing work even better. The method we're going to demonstrate is based on convolution, that is, summation of functions of a scaled window with a signal. This signal is prepared in a clever way, adding copies of the same signal on both ends but reflecting it, so we minimize the boundary effect. This code is based on SciPy's cookbooks example that can be found at this webpage. This is the code based on the convolution principle. Upon running this code, we should see the following two plots to see how the windowing algorithm influences the noise signal. The top plot represents possible windowing algorithms, and the bottom one displays every possible result from the original signal to a noised up signal, and even the smooth signal for every windowing algorithm. Another very popular signal smoothing algorithm is median filter. The main idea of this filter is to run through the signal entry by entry, replacing each entry with the median of neighbouring entries. This idea makes this filter fast and usable for one-dimensional datasets as well as for two-dimensional datasets, such as images. Let's see the code. In this example we use the implementation from SciPy's Signal Toolbox. Let's now run the code. We see in the plot that the bigger the window, the more our signal gets distorted as compared to the original, but the smoother it looks. Cool. Now, there are many more ways to smooth data that you receive from external sources. It depends a lot on the area you're working in and the nature of the signal. Many algorithms are specialized for a particular signal, and there may not be a general solution for every case you encounter. In this video, we've learned smoothing noise in real-world data. That marks the end of this section. In this section we have started off with importing data from CSV and Excel files. Then we moved on to importing data from tab delimited files, JSON resources, databases, and cleaning up data from outliers. Finally, we saw importing image data into NumPy arrays, generating controlled random datasets and smoothing noise. That's amazing. Hope you had fun learning. In the next section we'll take a look at how to draw plots and customize them as per our needs.